Imagine this. You're inside a metal cylinder surrounded by total darkness. There's no sound, except the whisper of machinery, the deep hum of life support systems, and the slow rhythm of your own breath inside a helmet. Outside, there's no ground, no air, no north, no south, only vast silent emptiness. Whether you're hundreds of meters below the ocean or floating thousands of kilometers above Earth, the scene feels strangely similar. But what if it wasn't just similar? What if somehow submarines could actually be used as spaceships? It sounds like something pulled from the pages of a sci-fi novel, and maybe that's exactly why it's worth asking, because sometimes it's the most improbable questions that reveal the boundaries of the possible. Let's start with the basics. Submarines and spacecraft are, in essence, capsules designed to keep humans alive in environments that want them dead. In the deep ocean, pressure crushes. Every meter of depth adds a new column of water pressing down on the hull. In the vacuum of space, the opposite. Zero pressure, but intense radiation, extreme temperatures, and a void that would suck the air from your lungs in an instant. Both are lethal realms, and so both submarines and spaceships must maintain a tiny slice of Earth inside them. Breathable air, stable temperatures, protection from invisible threats. They are floating fortresses in invisible oceans, one in the deep sea, the other in the cosmic sea. But here's the curious part. If a submarine is built to withstand the brutal crush of tons of water per square meter, wouldn't it be perfectly suited for space where there's nothing? At first glance, the answer seems to be yes. If you can survive the pressure of a liquid leviathan pressing on every square inch of your hull, surely resisting emptiness should be easier. But not quite. Imagine a balloon, a regular party balloon. Put it inside a submarine deep underwater. The pressure outside wants to crush it. Now take that same balloon into space. No pressure outside, so it expands and bursts. The problem flips. In space, the challenge isn't resisting external pressure, it's keeping your internal pressure from tearing you apart. Submarine hulls are designed to resist compression. Spacecraft, on the other hand, are built to contain expansion, to hold pressure in against a vacuum. It's like comparing a bank vault to an inflatable balloon. One is made to survive the weight of the world pressing in, the other to preserve what's inside from bursting out. But let's say we made some adjustments, reinforced the interior, sealed every joint, insulated every material. Could we, with enough ingenuity and resources, transform a submarine into a space capsule? Surprisingly, the answer is maybe, and that possibility opens some fascinating doors. Let's peek inside a modern submarine. There, we find life support systems, air and water recycling, powerful batteries, hermetically sealed compartments, and navigation guided entirely by sensors. No windows, no views of the outside world. Now consider the International Space Station. Astronauts live for weeks or months in a sealed environment, breathing recycled air, drinking reclaimed water, navigating with sensors, relying on computers to keep them alive, just like submariners, just like deep-sea explorers. Both environments are extreme tests of survival, engineering, and psychological resilience. That's why, unsurprisingly, NASA has trained astronauts in submarines. Yes, deep beneath the ocean, inside underwater labs, they've simulated interplanetary missions. Because the sense of isolation, of total reliance on technology, and the inability to escape are nearly identical. So why does the idea of a submarine in space still feel absurd? Because space and ocean, while poetically similar, are very different enemies. In the deep sea, the threat comes from outside. In space, it comes from within. Oxygen can ignite from the tiniest spark. Water can freeze or boil. Bodily fluids can vaporize. And worse, cosmic radiation, invisible, relentless, can pierce metal like ghostly daggers. A regular submarine isn't shielded against that. But what if it were? Here's where imagination steps in. Picture a spacecraft of the future, perhaps not so far off, built on the bones of a submarine. Cylindrical, dark, robust, outfitted with adapted engines, solar panels, internal heat control systems. It launches from Earth, floating into space like a cosmic whale, its armored skin repurposed to challenge the void. Its first mission? The Moon. Or maybe Mars. Maybe it carries supplies. Maybe it carries dreams. Maybe deep down, we're already building something like this, and just haven't named it yet. Because throughout human history, our greatest inventions often arise from fusing the improbable with the obvious. Our first airplanes borrowed from birds, our first submarines from whales. Who's to say our first orbital cities won't echo deep-sea vessels? Who's to say future space stations won't be inverted submarines? Not sinking, but rising above the sky with the same soul. Survival in the invisible. And there's something deeper in this comparison. Both realms, ocean and space, confront us with mystery. In the depths, bioluminescent creatures glide like silent thoughts. In space, nebulae shimmer like memories of dead stars. Two ends of darkness. Two kinds of beauty. The deep sea is a glimpse of our primitive past. The cosmos, a hint of our distant future. But both reflect who we are. Curious, stubborn, survivors. And perhaps that's why the idea of a submarine in space resonates so deeply. Not because it's immediately practical, though with some re-engineering it might be, but because it's symbolic. A sign of transition, of a species that once learned to survive the depths, and is now preparing for the skies. But let's return to practical reality for a moment. What would we actually need to turn a submarine into a spacecraft? First, thermal insulation. Space swings from 250 degree to 250 degree. We'd need outer layers that handle temperature shocks in seconds. Second, radiation. The hull would need to be reinforced, maybe with aluminum, composite polymers, or even water shielding, which helps block cosmic rays. Third, propulsion. Jet engines don't work in space. We'd need ion thrusters, magnetic drives, or even nuclear propulsion, concepts already being tested. Fourth, trajectory control. Submarines steer with rudders and ballast. In space, we need gyroscopes, microthrusters, and hyper-precise software. And of course, mass. Submarines are heavy, extremely heavy, and in rocket launches, every extra kilogram comes with astronomical costs. So yes, a submarine could, in theory, work as a spacecraft, but it would need to be reimagined, redesigned, transformed. Or maybe not. Maybe the value of the question doesn't lie in engineering. Maybe it's a metaphor. In the end, a submarine in space is like a poet in the desert. Out of place, yes, but full of hidden meaning. It's a symbol of something that carries life through silence, a capsule of hope, a boundary between the human and the infinite. And if we really think about it, we are all, in a way, submarines adrift in space. Earth itself is a sealed vessel, spinning through the void. We have air, we have water, we have food, warmth, light. And around us, nothing. Absolute nothing. A planet-sized submarine, traveling at 67,000 miles per hour around the sun, shielding our fragile existence with a thin blue layer of gas and hope. So maybe the real question was never, can a submarine go to space? But rather, aren't we already in space, traveling inside a cosmic hull for billions of years? And if one day we must leave this Earth, for curiosity, for courage, or for survival, perhaps our first spacecraft won't be something entirely new, but something remembered, something evolved. Maybe it will resemble what once guided us through the dark waters below, a submarine, reborn, adapted, ready to dive into the sky. Because in the end, whether beneath the waves or among the stars, what truly matters isn't the shell. It's the life it protects. It's the spirit it carries. It's the ancient desire to explore the unknown. So tell me, did this journey spark something in you? If this video stirred your curiosity, lit a new question in your mind, or rekindled your sense of wonder, take a moment to join this voyage with us. Like the video, share it with fellow explorers of science and imagination, and subscribe to the channel for more deep dives into space, into thought, into mystery. Because here, every question is a journey, and every journey is just the beginning.